So, is life possible on Mars? It's the question that's captivated us for centuries, isn't it? It's inspired science fiction and has driven real-world science. Is Earth really the only cradle of life in our solar system, or could our planetary neighbor be holding on to a secret? Let's dive into the science behind this age-old dream.
But this isn't just about ancient history. As we're gearing up for human exploration, we're forced to confront one of the most profound scientific questions of our time. Is there life on Mars today? And what would it even mean if we found it?
All right, first up, the Martian dream, the call to the red planet. Before we can even begin to look for life, we've got to get there, right? And for decades, humanity has been answering the call of the red planet, driven by this powerful, generation-spanning dream.
And that dream, well, it's quickly becoming a very real plan. We're in a new space race, with both NASA and SpaceX aiming for the 2030s to put the first human boots on Martian soil. But the ambition doesn't stop there. The long-term vision, pushed by figures like Elon Musk, is a self-sustaining city by 2054. This isn't just about exploration anymore. This is about expansion. So why go through all this trouble? What's the real driver behind such a monumental undertaking? The answer is both simple and profound: survival. Becoming a multiplanetary species is seen as an insurance policy against any catastrophe that could threaten life on Earth. It's all about securing a future for humanity, out there among the stars. Next, let's talk about the red journey, gearing up for the unknown. Okay, so the why is clear, but what about the how? Getting to Mars requires some of the most advanced technology ever imagined. Let's take a look at the incredible machines that are going to get us there. So NASA's approach is super methodical. You've got the Space Launch System, or SLS, which is the most powerful rocket ever built, designed specifically for deep space. Then there's the Orion capsule, the ship that'll keep astronauts safe on their long journey. And crucially, the Artemis missions to the moon, they're not a detour. Think of them as the essential dress rehearsal, a place to test our systems and strategies before we commit to the 9-month trek to Mars. And what's so fascinating here is that we've got these two parallel but also cooperative paths moving forward. On one hand, you have NASA's proven SLS and Orion system, which performed beautifully on its uncrewed test flight. On the other, you have SpaceX's ambitious Starship, designed for total reusability and Mars colonization. They're not just competitors. For Artemis 3, it's actually SpaceX's Starship that's slated to land astronauts on the moon, launched by NASA's system. So when we get there, what are we going to wear? Well, the answer might actually surprise you. The engineering for our next steps in the cosmos comes from a partnership between the aerospace industry and high fashion. A truly unexpected and kind of brilliant collaboration. Let's be clear, this is way more than just a fashion statement. The Axiom Prada spacesuit is basically a 200-kilogram personal spacecraft. Prada's expertise in advanced materials is being used for the outer layers to improve mobility and durability. Inside, it's packed with cutting-edge tech, and the boots, designed for the extreme temperatures of the lunar poles, are the perfect testing ground for what we'll need on Mars. All right, next section, hostile frontier, the perils of the journey. But building the right gear is only half the battle. Space is an unforgiving place. The trip to Mars isn't a walk in the park. It's a journey across a hostile frontier, and it is packed with dangers. Just look at the monumental scale of this journey. We're talking hundreds of millions of kilometers through the vacuum of space. For the astronauts, that means months of isolation, microgravity, and exposure to an invisible threat that is maybe the single biggest challenge to human exploration. And this right here, this is the big one. The invisible enemy, galactic cosmic radiation, or GCR. These are high-energy particles just zipping through the universe from distant supernovas. Here on Earth, our magnetic field and atmosphere shield us, but out in deep space, there's nowhere to hide. The crucial thing to understand is that the danger is constant. It starts the second you leave Earth's protective bubble. You have to punch through the intense Van Allen radiation belts really fast. Then, for the entire months-long journey, astronauts are soaking up a cumulative dose of GCR. And even when you get there, Mars offers very little shelter. Its thin atmosphere barely provides any shielding, and the soil itself is toxic, laced with chemicals like perchlorates, salts that are harmful to life as we know it. So facing dangers that immense requires an equally incredible motivation, right? Let's get into the next section, ancient life clues, following the water trail. The ultimate prize here is the answer to our central question. To find it, we start by following the trail of the most essential ingredient for life as we know it, water. Looking at this comparison is like seeing two completely different worlds. Nearly 4 billion years ago, Mars was a blue planet. It had a thicker atmosphere, vast oceans, rivers, lakes of liquid water. I mean, it had all the right stuff for life to get started. Understanding how it turned into the frozen desert it is today is the key to figuring out its potential for life. And look, this isn't just a theory. The mineral evidence is written all over the planet's surface. What you're seeing here is a global map of minerals that can only form in the presence of water, things like clays, sulfates, and carbonates. This isn't evidence of a few puddles. This is proof of a planet-wide watery history. Mars was once a water world. So, how do we investigate this watery past? We send our robotic geologists, of course. And the Perseverance rover, while it was exploring an ancient lakebed called Jezero Crater, made a jaw-dropping discovery. In a rock nicknamed Sapphire Canyon, it found something very tantalizing. The rover's instruments detected two specific iron-based minerals, vivianite and greigite. So why does this matter? Well, because here on Earth, in wet environments, like the bottom of lakes, these exact same minerals are often a byproduct of microbial metabolism. They could be a direct fingerprint of life. All right, time for our final section, the final verdict, a new genesis. So let's recap. We have a once habitable environment, and now we have minerals that could be biosignatures. Are we on the verge of the single most important discovery in human history? Are we close to a final verdict? The significance of this find really can't be overstated. Like NASA's acting administrator said, this is the closest we've ever come. Now, it's true that non-biological processes could potentially create these minerals, but finding them in a place that used to be a lakebed, that's an incredibly compelling piece of evidence. The final proof, of course, will have to wait until we get these samples back to Earth for analysis. And this brings us from the past right into the present. The evidence for ancient life is piling up. But what if, deep beneath the surface, shielded from all that harsh radiation, microbial life held on? What if Mars isn't a dead planet, but just a dormant one? This possibility creates a profound ethical dilemma. See, our long-term goal is to set up a human presence, maybe even terraform Mars. That is, change its atmosphere and climate to be more like Earth. But what if, in doing that, we're committing planetary-scale genocide against the only other life we've ever found? And that is the question that's going to define our future in the cosmos. As we stand on the brink of becoming a multiplanetary species, we have to decide what kind of species we want to be. Are we explorers, cataloging the wonders of the universe, or are we pioneers, willing to pave over one world to save our own? Is our mission to explore or to preserve?